Hi guys, so here we go again to wrap up the chapter and also the syllabus actually. Okay, so without further ado, let's look at the types and the components of pipes for cold water supply. We look at cold water supply because in our country, rarely do we supply the hot water into a building unless you're in a hotel. That's a different story because of the comfort, extra comfort. Okay, so in the installation of major pipelines, the categories of items we have the pipes, the connectors, the valves, and the special joints. A complete water pipeline that satisfies the design requirements, we use a combination of all these items. Think about it, it makes sense, right? You have the pipes, surely you have the connector connect between two pipes, maybe different sizes. You have the valves, we talk about the importance of valves in the water distribution system, right, for checking and all, maintenance works. And special joints, the pipe cannot possibly be going in a straight line all the time. You need to take cornering, you need to raise them to a certain elevation, so that will all take special joints, okay? Right. And what is the definition of pipes actually? So in general, we say it's a round tubular section or hollow cylinder to convey media. So in this case, in our context, we talk about having the pipes to convey water, obviously. All right. In other industry, it could be conveying things like liquid petroleum. It could be conveying chemicals and things like that. But in our case, it's about water. Alright, and just take note of this fourth point here. When we talk about pipes, we specify them in terms of the internal diameter, alright, and the wall thickness. And usually the term that we use is the nominal diameter. And remember, the nominal diameter that we mean is actually the inside diameter. Okay, so to know the diameter of pipe is to know the nominal diameter, and then we talk about the wall thickness, because that will determine the size of the fittings and so on that you are going to use in combination with the pipe, right? Okay, very quickly, these are the common methods that people use to form the pipes. I have not seen any of these myself, so I'm not going to pretend I know and give you elaboration on that. But I believe if you are interested in any of these, you could look up in the internet, the YouTube. They probably will show you some of these from the industry. If it's not an actual video recording, because some of these are happening at high heat, so maybe it's not suitable to take a video and see what's going on, like in the butt welded type in the furnace. So maybe an animation will be helpful. Nonetheless, I'll just draw attention to the beginning of the process. We have billet. Billets are essentially, we call metal billets. It's a length of solid metal to be processed into whatever you want. So in this particular case, the seamless pipe, apparently under heat, you roll it, and there's a piercer going through to form the hole in the middle, the hollow bit. Alright. So again, I said you're interested in any of these, please go on the internet, go on the YouTube and look them up. Okay, let's take a look at this piping material. Okay, what are being used? What are the materials that we use to make these pipes? I'm sure again that you already have an impression, right, of what kind of pipes we have around in our house, in the labs, and so on. So let's take a closer look here. Pipes can be made from a variety of materials, and in the past, interestingly, materials are usually wood and lead. Okay, the construction materials, most of the things are made of these two. And for pipes, this is the interesting bit. Lead is plumbum in the Latin, and that is where we get the modern word today in English, plumbing. Alright, plumbing system. Berpaipan is called plumbing system in English. Alright, it's a silent B, bukan plumbing, it's plumbing. Alright, just like a bomber jet, we don't call it bomber jet, we call it a bomber. Alright, it's a silent B. And these days we can have pipes made from the different materials, starting from asbestos cement pipe, UPVC or PVC, mild steel, and so on and so forth. Later on in the subsequent slides, we're going to take a look at some of the more common ones. Okay. Now, according to SPAN, remember the Suruhanjaya, there's a uniform technical guidelines for water regulation and plumbing, and about the materials of the pipes that we use. And according to them, all materials used in the construction or supply mains, service reservoirs, pumping stations, external reticulation systems shall conform to those which are registered with the Commission. So in other words, the contractors need to inform the Commission about the Commissioner on the materials they are going to use for the pipes, because these are, again we say, they carry high pressure. We tap from the main, and when they are sending in to the users as service pipes, they are buried underground. So we cannot afford to have low quality stuff or pipes that are of unknown quality, unknown specifications are being used. Right? The commission, the CA is a certified agency, or WDL. Remember WDL is the water distribution licensees that we saw earlier on, reserves the right to inspect the materials before use. And usually these authorities will come in to look at the materials, look at the pipe, check that the spec sheet is all correct, complying to the standards before they are being installed. Right? Any unapproved materials or products, including those that are incorporated in your computer work, can be cleared from site. In other words, contractors who do not abide by these stipulations, even if the work is done, all the pipelines are fixed in, you can be asked to remove them. And we know this is common in civil engineering works, right? And we can look at some of these tables here that tell us the details on it. Let's take a quick look at the table B61 here, all right? The laying conditions and pipe material. See, non-corrosive soil and the corrosive soil or coastal area. Okay, you see, when you have situations in a corrosive soil or coastal area, coastal is obviously, we're talking about salt water. Corrosive area, we could be talking about somewhere where the soil condition is acidic, like somewhere where it's highly organic soil or peat layers in the ground. So in these situations, we probably recommend the HDPE, high density PE pipes, ABS pipes. ABS is a kind of thermoplastic, high strength thermoplastic, or we could also be recommending the use of GRP. GRP glass reinforced plastic, right? Or PVCO. PVCO is upgraded version of PVC pipes, and it has 10 times, right? Approximately 10 times the impact resistance of ordinary PVC pipes. Okay, and you could also use ductile iron or mild steel, but there's some notes there. You could take a look more in detail on the internet. You can find this all out in the standards. All right, if you want to. What I'm trying to say here is that by looking at the tables, you can see that when the soil conditions and the area you're going to use install these pipes change, from a non-corrosive place to a coastal area, from a normal residential area to an industrial area, and the type of material for the pipes will vary, depending on the needs of it. Okay, we'll quickly go through 7 of the common pipes that we come across. Asbestos cement pipes. You see a lot of these on the roadsides when they are laying the pipes, right? The white color thing with black ends. So these are the asbestos cement pipes. They use they're made of cement, asbestos, and silica. And the diameter is between 3 inches to 24 inches. These are commonly used laying on the roadside to tap from the main. All right. The UPVC and PVC pipes, we see this a lot. They're easy to be cut and installed. That's why we use this a lot. They are suitable for transporting water because they contain the type of UPVC plastic and smooth pipe ends. We like that. It's easy to install to prevent leakages. Plastic is this is actually one of the newer materials in making pipes, and these are the size ranges that we have. Okay, mild steel pipes. When we talk about mild steel pipes, there are actually 3 subcategories: the soldered iron, the seamless iron, and the galvanized steel pipe. So remember, the galvanized steel pipe is under the category of mild steel pipe actually. And the diameters as such, and you can see that it's mentioned here, for the soldered iron type and the seamless iron type, they are easy to rust compared to the galvanized one. So this galvanization, this process of protecting the steel pipe is actually making it more lasting. Alright, and in order to prevent the soldered iron and seamless pipes from rusting, what do? They actually coat the inside with concrete, alright, a thin layer of concrete, and on the outside they put a bitumen coat. And on top of that, to make it sure that it's strong, they put reinforcement of fiberglass. So it's not just an ordinary pipe now; it has a lot of coatings inside out, and there's a reinforcement going on. And these pipes can come up to 30 feet or 9 meters long. Alright? So it can be used for as a service line, so it's easier to connect longer sections. Right? Steel pipes. So these are stronger than the cast iron pipes, resistant to high water pressure, easily transportable. However, they have a weakness or shortcoming. They are easy to rust. Alright, because of the water inside. Hence, their life expectancy is not very great. It's like 50 years or so, so it's not considered a very durable material, despite all the good stuff about it. Okay. Next, the concrete pipes. You see a lot of these as well on the roadside. Usually they're precast, sent to site, and they will install it. So these are common. They can go up to 1.8 meters or even larger. The cost of maintenance is low because they are very durable. They are very resistant to corrosion. Basically, they don't corrode, right? However, they are not resistant to high pressure or weight. Buried, placed properly, on the bedding material and covered nicely, sufficient depth, or you have too much load on top, like a heavy truck or heavy traffic, you can actually break it. Alright. Next, we have the PE pipes, and again, these are commonly found. You can see these on the roadsides as well. So there are two types here, the low density ones and the high density ones. So LDPEs, as you can see here, these are bigger diameters and they are sturdier, but the ones that they come in rows, they are the high density ones, the HDPE. Right, you see a lot of these as well on the roadside, not placed on the roadside, deposited on the roadside by the supplier to be taken in to service the inside residential area or kampong. You must see a lot of these on the roadside. Alright. Okay. And last but not least, we are looking at the copper pipes. These are very high tensile stuff, lightweight and easy to handle. We know copper is a very valuable metal in construction. It can be bent, easily formed in other words, and it has a smooth surface, inside surface. So for those of you who are doing B&B, probably familiar with the copper pipes used in what? Yes, used in our AC system, air conditioning. Why? Because copper is a very good heat conductor. Right? If you are talking about AC, then you can use them to carry off the heat very quickly. Right? Okay, now let's take a closer look at the pipe sizes and what we mean by nominal pipe sizes and nominal diameters. Okay, there's several systems around actually. They're pretty standardized, but it depends on which one you're looking at. So some interesting point has been elicited here by Faizal, so I'll just go through with you. What we call the NPS or nominal pipe size is actually a Northern American thing, right? They are used, we are talking about pipes for high or low pressures and temperatures, and basically for all sorts of applications, right? And the pipe size is specified with two non-dimensional numbers, a nominal pipe size, that's the NPS number, based on inches, and a schedule that tells you the wall thickness. Remember, at the beginning of this video recording, we mentioned that to describe a pipe or to tell the size of a pipe, we'll talk about the internal diameter or the nominal diameter, and we need to know the thickness as well, because two pipes may have the same nominal diameter or internal diameter, but because of the different wall thickness, then that would affect the subsequent design in terms of the fittings and the connections. Alright. And there's another system called the nominal bore, MB, and this is normally used interchangeably with NPS, okay? And in this case, in this system, designating the outside diameter allows the pipe the same size to be fit together no matter what the wall thickness is. So for the MB system, they tell you the outside diameter, and we just discussed about it. It makes life easier for people to find the contractors rather, to find the fittings and all, okay? And the next one is the diameter, nominal diameter, depending on how you say it. It's a European set of standard size, and they are measured in the metric unit, in millimeters. Okay, and as we said earlier, there are many international standards that tell us about these pipe sizes, because these are pretty standard stuff. Okay, we have the German system. Remember, standards or the specifications that come out with DIN at the front, they come from the German institute. Is similar to our CRIM, or similar to the American ASTM, right? American Society for Testing Materials, similar to the British Standards Institution, BS. And however, note that they have the EN at the back. Right, BS and EN. So EN stands for Euro code. So we do know that in the Europe, including the UK, they share these common standards, if you like. And so these days, even BS, British Standard, is slowly being phased out to be replaced by what we call the BS-EN code. Alright, you do concrete design, you have already done, I presume. You will notice that you probably refer to Euro Code 2 and EC2 instead of the normal British Standard, the BS-8110, as I was taught many years ago. Alright, so these are the systems they have. We also have API. This is also commonly used when we talk about the sizes of pipes. API stands for American Petroleum Institute, so obviously the oil and gas industry will need some kind of standardization in terms of the pipe sizes, because they use a lot of those to transmit that, whether it's a crude, whether it's a processed crude, or whether it's liquid petroleum. It could be anything. Alright, and we also refer to ASME, that is the American Society of Mechanical Engineers. Alright. So we continue a little bit about these sizes. You see, if we are talking about the MPS method, it says here that for pipe sizes less than DN350 or equivalent to MPS 14 inches, both methods will give you a nominal value for the OD, that's the outside diameter, that's rounded off and it's not the same as the actual OD. For example, MPS 2 inches and DN50 are the same pipe, but the actual OD is 2.375 inches or 60.325 mm. You can cover this yourself. The only way to obtain the actual OD is to look it up in a reference table. So it sounds a lot very confusing. It's okay. I just want to show you that when next day if you happen to do your LI or to work in a place that deals a lot with pipes, for instance, you probably work with SAMB or SAJ or do your LI there, and you'll be aware of how people look up these sizes, okay, the pipe sizes. And this is an example of it. As you can see, an inch is 25.4 millimeters, yeah, just in case you're not familiar, because you do not learn imperial units. Neither do I actually, but many of these American standards still refer to the imperial units. So in fact, strangely, the imperial units came from the imperialists. So we're talking about the British and Europeans, but they have gradually phased it out. But the Americans seem to be using it a lot. Anyhow, so this is how it goes. You can convert it yourself if you want to, right? The outside diameter given is MPS inches, the NMM, the outside diameter, whether you want to talk in terms of inches or mm, and then the wall thickness are given, you can see. So just telling people the diameter is not good enough, because two parts can have the same diameter, but they have different, up to 4 different types of wall thickness. Okay, this is the schedule, the specifications that they meant early on in the notes. Okay, here are the joints. So take a look carefully. You see that there are some are common. We have seen them before, like probably this is common, plain A and T, all the same sizes, right? And you probably have seen these flange T as well, similar to the plain in ones, but they have flanges coming out, macam bibir, okay? And the elbows and so on and so forth, okay? And the valves, all right. What are valves? Injab, okay? They are devices that are used for controlling the flow of fluid, liquid in the pipeline, because in this case we are talking about water, right? And with the use of valve at any section of the pipeline can be isolated for the purpose of inspection, repairs, and so on and so forth. So we talk about this many times throughout our lecture. Valves are important in the water reticulation system to ensure that you can isolate, separate apart a section of the distribution system for maintenance work, of repair works, without affecting other people, other parts of the area. Okay, and these are the different valves that we have. You have scour valves, air valves, relief valves, and all sorts. You could look into these more in detail if you like. Okay, these are the examples here. If you just let's take a quick look at some common ones that we have seen. This is common. Between the two pipes, you see there is one. We will say ordinarily you say it's a pili, kepala pili, right? It's a tap, but actually it's a stopcock. You see, it's a stopcock. So if we were to turn this off, then the water will stop flowing between these two sections. You can see here. Okay, and that's the gate valve, similar idea, but it's a sturdier version. Usually this is plugged onto the service outside the house. Okay, air valves usually have these in the cistern tank to prevent overflowing. Okay, you can look more into details about this if you like. Okay, now we go into the building, and the water comes into a house. Let's talk about just a house, a residential unit. How is the water being distributed within the building? So we have 3 ways of doing it. You can do it the direct way, the direct system, go through the indirect system, or a combination of both. By the time we finish discussing about these 3 systems, hopefully you will get an idea of which is the ones that we commonly encounter and which is the one that you will recommend if you are designing the water system, distribution system for a house. Okay, the direct system says what? It says that your supply comes directly using the service pipe. It's not suitable to supply water in high-rise. We talked about this much earlier on. For high-rise building, what do we do? It's a flat apartment or a block of condominium. What do we do? The water must be pumped up to their storage. Then from the storage, it comes down to individual units. It could be gravity flow. Sometimes they use a pump as well to make sure it's more efficient. Okay. Hence, a direct system that comes directly from the main cannot be used for a high-rise building. And what are some of the features of a direct system? Water is clean and fresh, obviously, because it comes straight from the main, right? It needs a high water pressure. There's no storage tank required. If there's a disruption, there's no water stored. So if the main is cut off for whatever reason, then you have no water supply. And any damage or leakage can be difficult to detect, obviously. The indirect system, how does it work? The supply of water is indirect by having a water storage. So water from the main comes in and gets stored in the tank first. And the service pipe, you take your water from the main pipe to the storage tank first, as I said earlier on, and then it's stored in the tank. Usually for a normal household, it's usually 227 liters. These are the black FRP tank that we usually see in houses. Okay, and what are the special features of this system? If there's a water supply disruption, no worries, you still have water supply because you have a tank up there. The water supply is fixed. During high demand, the system can have to reduce supply of water from the main because you can tap from your storage. And the clearness of water can be ambiguous, it's not guaranteed. That's why from time to time, maybe every 2 or 3 years, you should get someone to go up there and help you wash up the tank. Alright? Because it's debatable. You say that if the water coming in from the main has been treated in the plant, when it comes, it should be clean enough. But as we said, cleanliness of the water quality is a very subjective matter. If it is safe to be distributed, meaning that there may still contain some sediments, but the water itself is safe. And some sedimentation is expected to take place in the storage. So with time, you can imagine the storage tank up there in your under your roof will be coated with sediments. And when there's too much, and every time the water comes in, it will mix up the water, right? Kochap. So and you start opening up your tap and water comes from the storage tank. Of course, the water that comes out is not as clear as you want it to be. So this could cause problems. If some of these sediments are actually oil-based, they could stain your clothes when you're using a washing machine, for example. I'm just speaking from personal experience. So I had such a problem until I get a technician to come in to help me wash up the tank, and that is like a filth that is like 2 inches thick. That's scary, really scary. Okay. Not to mention the situation where while it is our storage tank is usually under the roof and in the ceiling space, right? We say it's quite safe, but it's covered, right? Even if it's outdoor, it's covered, but sometimes pests will actually go in, dead rats and things like that. So I think it's important that if you could, a year once or so, just have a quick check of it, right? And we continue with this. The feature is that the cleanliness is, we talk about this, is not quite guaranteed, and there's a ball valve that prevent overflow actually. So if that is broken, then water will be overflowing out. That is not nice, that's wastage. So again, you got to be checking that. Okay, now here, this is a combined system. Alright, take a look at it. Okay, all water will coming from the main, right? Nicely come in. Let's take a look at the direct system. That's a red line. Okay, it comes in. Where does it go? Pop, pop, pop. It goes into your kitchen sink. Can you see? If you have a bathroom somewhere around the kitchen area, it will go into your bathroom as well. That's why that is the shower room that has the best shower in the house. You will probably say, unless your house has got a personal pump. Okay, because it comes from the main. But for the indirect system, it comes in, goes right up into your storage tank first, then it comes down to be distributed to all over the place in your house. So this is a combined system, and if you think about it, you see a yes. In ordinary installation, the approach, we will find this in the residential units, because this will save the trouble of having too low pressure in the place that is most needed in the house, the kitchen area, during peak hours, and a storage will ensure that if there is any water stoppage due to maintenance or repair works, then you always have certain amount of water up there for the usage of the people in the unit or in the house. That's why storage tank is very important, and it is also can be an issue when you come across unscrupulous contractors who supply or to install this individual storage tank that is actually too small for a particular household. Double-story house, 3 bedrooms, you expect at least 5 to 6 people staying in the house, and the water storage should be at least sufficient to supply for the people in the house. Ordinary usage, you do not run a bath when you are having water shortage, right? So ordinary shower, using the toilets, ordinary cooking, no wastage. Probably you don't use a washing machine for some time. So the water supply, the storage tank should have enough water for the whole house, the entire household, for like 2 to 3 days. At least 1 day. But as I said, some unscrupulous, unethical contractors will give a small tank for a big house. So if you have if there's a water stoppage, no water coming from the main, then within half a day, the tank is empty. That is a problem, right? If you have old people in the house or babies in the house, and the water tanker has not come in, then you have a trouble, because water is not just about cooking and washing, it's about hygiene, right? Imagine your loo, it cannot be flushed, so that's an issue. Okay, so bear that in mind next day when you work for a contractor or you become a contractor yourself to develop houses for people. Okay. So coming to the end of this part, we look at some more details about the pipes that we find in the building. All right, the connection pipes. What do? They connect the main to your water meter, allow water to flow to the storage tanks and the parts of the house. Usually they are galvanized iron. We also call them vertical pipe. Why? Because it can flow to the storage tank up in the upper level of your house, and the distance from the boundary is about 300 mm. So these pipes are actually coming from the main, so they are actually outside your property line. Alright, so it's about a foot away from your property line. Within your compound, there should be a line there. So if you are trying to do some gardening work, be careful when you're trying to loosen the soil or things like that. Do not tu hayun itu campur kuat sangat, dah terkena pecah atau bocor. Another problem. Okay, the service pipe, they connect the water from storage tank for churning it out and cleaning. Also allow water to go into the house. Usually galvanized iron. We also know as galvanized pipes. We also know vertical pipes. The distribution ones, what do? They allow the water to flow out the tank. Usually are PVCs, smaller okay, the smaller one It could also be galvanized, and this water supply is subjected to the pressure of the tank. Your water tank up there, water come down to flow to other parts of the house. So it connects to the storage tank to usually sanitary fixtures, the toilets and the bathrooms and all. What are the cleaning pipes? These are the ones that are mounted at the base of your tank to channel the water out when you are doing cleaning. Usually they are just steel or PVC pipes, and there's a gate or valve to control the outflow. Alright, when you are not doing cleaning, of course you keep it closed, otherwise the water will be flowing away from your tank. And the overflow pipe that is slightly above the full water level of the tank, as the name tells you, for overflowing. So you can fill the tank so much, and then the ball will rise and close the valve so that the water does not overflow the rim of the tank. Okay. Alright, this is the last slide of the topic actually. How do we read the water meter? So after this, I hope you go out of the house and take a look at the meter and try to read it. So it says here, there are 8 digits, okay? And the first 4 digits are actually giving your water usage in terms of meter cube. The remaining 4 are actually in liters. So if you recall, when we do our mechanic bendalier or hydraulics, usually say that 1 meter cube is about 1 liter, right? But apparently there's a slight difference there, as you can see. 1 meter cube is like 8926 meter cubes. It's actually about 9128 liters. Alright? And this is a situation where the pipe size is such and such. So this is how we actually read the meter. Now you are good at reading the water meter, you can actually do it and cross-check when the bill comes. Okay, so that is all. That's a wrap for the chapter and also for the syllabus. So that's all for now. Bye-bye.